So you should be able to see the Terraform HashiCorp uh, logo on my screen. You guys are able to see?
Yes.
Yes.
Okay, awesome. Uh, so, I mean, before on this session, so basically, you guys already might have heard about Terraform and someone might have practiced. And few has, maybe you guys know more about Terraform. So basically, Terraform is a product of HashiCorp. So HashiCorp, it's an organization and they have introduced Terraform. So in the market, people know this product as Terraform, but very some people know the name of the HashiCorp, but they are the people who introduced this Terraform. So yeah, and we are using Terraform. This is a infrastructure as a code. What do you mean by infrastructure? Is the first point here. See, guys, the way I teach is quite different comparing with other. So we'll review some real-time scenarios also, so that because this will help you guys to understand more and more about how these tools or Terraform can be used in the real-time world. Because if we try with some normal things, I really don't think that gonna help us in our future. So that's the reason. Let's try with some real-time examples also. So, and this Terraform it's actually lets you use both cloud and on-prem also. If you want to manage your infrastructure using the code, then Terraform supports cloud and on-prem also. So what are the cloud? Most of the cloud services like AWS, Azure, Google, all these will be, I'll show you what are the providers also that Terraform will support. I'll show you detailed information. And also, this is the best advantage of the Terraform is it is a human readable language. And also the file system is, it's basically a human readable file system also. So the same code we can use, we can use multiple times. That is called code reusability. We'll be doing it. So that's it. These are all the some it's like these are the resources would be able to manage. But again, Terraform supports the end-to-end Azure development and the DevOps development. So we should be good.
If I may ask something.
Please go ahead.
Yeah. What is end to end? Like, what do you mean by end to end of that?
Okay. So let's say if there is a client, uh, let's say some customer, client, or anyone, they want to deploy their infrastructure, or they have their current infrastructure which is hosted on some cloud services. The cloud can be Azure, AWS, or Oracle, or GCP, anything. So right from start of the creating the subscriptions and assigning the management groups, creating the management groups, and their entire infrastructure can be deployed, can be managed using the Terraform code. No manual intervention. What I mean by manual, see, going into the Azure portal, the admins or some contributors will log in into the Azure portal and they perform all the manual changes on the Azure portal. So even those changes also, we can make it on code and it really doesn't require any manual intervention. See, the concept of DevOps is, and the concept of infrastructure as code is, it is again, if you guys are writing a Terraform code, that means you guys are actually a DevOps people and you are working on the development of the infrastructure, not at the application. So end to end is like right from starting, creating the resources, managing everything, the life cycle of the resources, everything can be managed by Terraform without any manual intervention. And that's the concept of DevOps. So we do not do anything manual changes, only using the code. Did I answer your question or should I try it in a different way?
Oh, yeah, I mean, I got a confusion between the CI/CD and this Terraform. So if there is
Hmm.
any relation between this, I mean,
Ah,
if you take CI/CD, right, it will automate the whole deployment process and delivery process, right? Uh,
exactly. You're correct, but there is a small bridge that you have to understand.
mhm.
Okay, let me give you a quick. See, you might be able to log in into the Azure, and you will be deploying all the resources manually. Let us take, for example, you have a Azure portal. You log into your Azure portal manually, and you deploy all the resources manually. That's a manual job. So
Right.
what is Terraform? Is basically Terraform. You write the script to create the resources inside Azure, right? What is Terraform, guys? You write the script or you use the Terraform script to create or manage the resources on the cloud. But if you write the script, will it be deployed automatically? No,
Mm.
because your script is in your repository like Azure, like a Git repository or in your local system also. You might have VS Code and you have downloaded the I mean, Terraform, and you are using you have written the code of the Terraform. So CI/CD, it's a medium basically. It's a pipeline to execute your code. You have written a code for a virtual machine. You have written a code for the virtual network, but how this code will execute? So with the help of the CI/CD, continuous integration and continuous deployment, or with this, you will be executing the code. CI/CD is a pipelines. It's a medium to execute your scripts and your application code and your Terraform infrastructure code. CI/CD does not create any code. It is a pipelines to execute your code. What is pipeline basically? As to make it more understanding, pipeline is basically a sequential order of some steps you are executing without any human intervention. See, even if you want to execute manually, you have to do all the steps. Instead, we are automating with the help of CI/CD for the continuous. Whenever you have the code, the pipeline will execute and it will perform the job instead of the manual. CI/CD does not create any code. You have to write the code, and this code will be executed inside the pipelines. How it will be executed, we'll show you in the next labs.
Okay, so can we call it as the upgraded version of Ansible, where we use Ansible for configuration of infrastructure, right?
Yeah, I mean, basically, yes, for configuration of the infrastructure. So we
Okay.
use Ansible also, but Terraform these days, because Terraform supports multiple cloud providers. Also, I mean, for example, you have Azure and some other you have on the, I mean, you have AWS also. So how you will be able to manage? So that's the reason this is much more, and most of the organizations are actually using these Terraform tool these days.
Okay, yeah, thank you.
Okay. Yeah. All right. Moving ahead. Okay. How does Terraform work? See, when you are writing a code, and how this code, when you have written the code for Azure, how it will know that you have written the code for Azure, and how it will be connected with the Microsoft Azure backend. See, basically, when you write this Terraform code or the configuration, then we will have some backend configurations we have to do. The backend will tell that, oh, this is for Azure. So we are supposed to connect to the Azure. Then it will connect to the target API and it will be deploying and managing the infrastructure. Always, and again, remember, Terraform, it's a configuration for the infrastructure. Terraform does not create any application code. It is purely a IAC, infrastructure as code. So this doesn't connect with any of the application development. So that is how the Terraform works. So basically, the Terraform provider will be connecting with the target API of the Azure or GCP or AWS. So it's gonna connect. So What is the workflow of the Terraform? How? There are certain commands, those needs to be executed. And coming back to your question, I think someone asked about difference between CI/CD. See, you see here on my screen, this is step 1. This is step 2. This is step 3, step 4, and step 5. These are all the sequential order we have to follow, right? 1, 2, 3, 4, 5. 5 may not be required all the time. It depends on the scenario, but only till 1 to 4 is the regular day activity we do. So this is how even the pipeline will execute. How the pipeline will execute: once you have written the code, it goes to init, validate, then plan and apply. Apply is for creating. Plan is for execution. But let us understand what is this validate and init, plan and apply. So if I go back, here what we have discussed, when we are writing the Terraform code, it will be connecting with the provider information, and that will be actually connecting to the target API, right? So that's the first step here. Init. This is like initializing the Terraform. When you are initializing the Terraform, that is where it will identify who are the providers and what is the version of the providers and what are the resources we are going to deploy based on that. I mean, in case if we are using some modules or anything, then what modules it has to download everything. This is the part of initialization. Then comes the next step is validate. What is validate? Whether you have written, you do not require any other person. So only this will tell you whether you have written a valid code or not. So that's it. You don't need a second eye to check. Terraform is actually a second eye where this provider will check whether your code is valid or not. So here this will check what is whether the whatever you have written, is it actually following the correct syntax? Is there any syntax errors or anything? So this is the validate. Then comes the plan. Plan is once you have code, once your code pass the validation, what your code is going to do. Are you creating a resource group? Are you creating a virtual machine or a storage account? What it is going to do, it will tell you, hey, your code is actually going to create a storage account. This is where. So this is where you can see the configurations, whatever the configuration. What do I mean by configuration? If you're creating a virtual machine, what is the size of the virtual machine? What is the operating system of the virtual machine? And if you want, what is the additional data disks of the virtual machine? All these, where you will see over here, whatever the code you have done, what are the things it will going to create or manage? It will show you this plan. After that, then it goes to apply. Apply is like, if you are comfortable with all these plan, if you feel like your code is actually behaving as per the expectation, then you can apply. The same resource will be deployed. Destroy. Destroy is nothing but you created something, you tested it, now you do not want it, then you can destroy it. That's the simple thing. Destroy is nothing but deleting the resource, guys. Again, this is just the workflow that I want to explain. And these are some data types. What are these data types? Please ignore. It is very early stage to understand what are these data types and everything. But today we'll do some small example, and that will make you understand how easy the Terraform with the help of these data types. So, and again, there are multiple Terraform top level blocks. With the help of these top level blocks, like Terraform block, provider block, resources, these are all, you might be saying these blocks, maybe you might get confused, but trust me, these are so simple, and I'll make it so simple, guys. So really, you doesn't need to worry about it. These are our very simple things. Why people experience challenges while implementing is because they do not understand. Otherwise, they do not, get the concept how these things actually operate. So if you know how to operate a particular system, then you should be able to handle, or you should be able to, perform very well. But in case if you do not understand any particular, particular knowledge, in case if you're lagging in it, then you would experience something. So these are some top level blocks. So here we are specifying the Terraform block. What is the provider configuration? What are the resources blocks? And what is the variables? How we will pass the variables? Outputs, how we will pass the outputs, and also some local values. In case if you want to, define a specific values, we should be able to pass the local values. Then data sources, and this is the main example. You see modules block. This is the heart of the Terraform, guys. Remember. So let me ask a quick question. If someone is creating a virtual machine on Azure, uh, I mean, normally how much time will it take to create a virtual machine?
Less than 5 minutes.
Maybe if you're creating some basic virtual machine, less than 5 minutes, but you have to add the, additional data disks, and also you want to add the backup for the virtual machine, and also you want to, create a VNet or some specific subnet for the virtual machine. In case if you want to do some, also there is a additional extensions we can add, like domain join or MMA extension, the monitoring extensions, all these. See, you guys deploy virtual machine in your lab because those are some basic virtual machines and you deploy it in 5 minutes. But when it comes to a real-time project or a real-time organization, a virtual machine, even for an expert also, it will take 15-20 minutes to create, guys. Okay. So 15-20 minutes. Let's take 20 minutes as the rough time. And suddenly, and today, client says, I want 100 virtual machines. Because of their, some DR strategy or the disaster recovery strategy, or they want to add another environment and they want to create 100 virtual machines. Now, if each virtual machine is taking 20 minutes to create 100 virtual machines, how much time will it take? 2000 minutes. Right?
Yes, you are correct.
Okay. Why these days everybody is behind Terraform? Why everybody is looking for infrastructure as code? You guys need to know the real example. Then only you will understand what is the use of it. I want to create 100 virtual machines, and each virtual machine takes 20 minutes. So how much? 2000 minutes divided by each 1 hour has 60 minutes. So you require 33, hours. So on a day, we work for only 8 hours. Am I correct, guys?
Yeah, yes.
Yes.
Okay. We work for 8 hours, guys. So now customer says, we are saying 4 days or 5 days to create. But again, when you're deploying, one virtual machine will be deployed easily, but another virtual machine will throw multiple errors because you have to keep it in availability sets. Otherwise, you have to add availability zones, all these. So let us take, if these virtual machines are taking to create, in 4 days, creating 100 virtual machines is not easy. This, as per my experience, this will require at least 7 to 8 days to create 100 virtual machines manually. Okay. And client says, no, I don't have that much of time. Let me open a notepad if I can. Yes, please ignore the other things. Okay. So now this is taking 8 hours per day, and we are taking 7 to 8 days for creating 100 virtual machines. And if it is a critical deployment, do you guys think in an organization the client will give you 7 to 8 days? Because inside this 7 to 8 days, remember guys, we have Saturday and Sunday also. We work from Monday to Friday only. So 5 plus 3, and we have a weekend, Saturday, Sunday in the middle. You will have almost 10 days it is taking, for a VMs to create. Do you think in critical situations, client will give you 10 days of time to deploy a VM? Because of their business, see, even client is not some kind of an enemy. Because of their business reasons, they won't be able to give you 10 days. They'll say, hey, can you make it in 1 or 2 days? What they will simply say is, make it in 2 days, or max to max, I can give you 3 days. Can we achieve this manually in 3 days? If I need to create 100 virtual machines, guys?
No, we can't.
Not possible. If I call some Iron Man or some other guy also, manually I'm speaking, they wouldn't be able to do it. But guys, remember, with the help of the Terraform, I can deploy 100 machines in 2 days. How? I'll write one VM code. So one VM code I'll deploy maybe in 4 to 5 hours. This will take one VM code, or I'm saying one VM code requires 6 hours, guys. So we are actually deploying a VM, one VM in 6 hours using the code. Actually, this is taking time, right? But here, Terraform has some meta arguments. So one VM code can be executed for 100 times or 1,000 times or infinity times. So 6 hours and another 2 hours to execute this VMs 100 times. Even I can make the entire VM. All the VMs can be deployed. 100 machines can be deployed in a single day also. Or you can deploy it in maximum 2 days also. See, that's the power of automation, guys. What is the power of automation? Manually, you require 8 days. Almost, as per our example, it is taking 10 days. But with the power of automation, I can make it in 2 days. That's the reason everybody is behind this infrastructure as code. Am I making sense, guys? Why everybody is behind infrastructure as code? What is the actual reality? Is this where this will save cost for the organization? And also another, okay, is it only for the cost? No, there is another thing. For example, the person who asked the question, he has contributor access. Multiple people everybody in my organization has contributor access on the Azure portal. And the person, sorry, I missed your name. What's your name? Sorry, I missed it. Just for example, Vishal, right?
Yeah.
Yeah. So Vishal is our employee, and everybody in our team has contributor access, guys. Okay, but unfortunately, Vishal and me had some let us take me as a manager. Me and Vishal had some kind of heated organization, and he is leaving the organization. Now there is a chance that he can destroy anything if he has entire access to the Azure. Even for example, take me as an example. I'm not happy with my organization. I'm leaving. If I have entire access or privileges, I can do anything. Even I can delete a database also. Then where is the security when it comes to manual intervention? See, if I have access, I can do anything. Then if everyone can do anything in my team, then do you guys really think we have a secure environment?
No.
No.
No, sir.
If anyone can do anything, then how our client will trust us? Because clients say, hey, anyone can do anything. Even that person, Rinkesh, can go and delete a database. If I give you my project, how do you do it? Again, we have a role-based access control, but I'm the manager. Maybe my teammates do not have. I'm the manager. I'm not happy with my organization. I deleted something. What will happen? Or by mistake, I mean, not wantedly, by mistake, I've done something. What going to happen? So coming to the infrastructure as code, no manual jobs. So no manual jobs or action. So everything will be over code. So even if I write the code, you might say by using the Terraform destroy, we can destroy the resources, right? That might be another. So that is where the CI/CD comes, guys. Someone, yeah, I think Vishal asked, what is the use of CI? That is where you will have the pipeline. See, you are not executing this code manually. You are executing this code through pipelines. And pipelines, you will not have control over the pipelines. Only few things you will have control to execute, like deleting, and also CI is basically building a solution or building your plan, Terraform plan. CD is the deployment. When you're deploying, you will not have approvals to deploy. Only a senior person or an architect will be approving the pipelines. That is how the CI/CD flow. So you cannot go and deploy that. That is not, see, without this also, we can create pipelines, guys. But how an organization work, you have to understand. That's the reason everybody is behind this CI/CD. Everybody is behind this, scripting code or Terraform or scripting. Now, am I making sense, guys? How the reality is?
Oh, yes.
Okay. So that's the major advantage of the Terraform, guys. And how you will create 100 virtual machine, coming back to example, with the help of the modules block. See, the main advantage of the module is you can create one virtual machine code, and that virtual machine code can be executed for 100 times. That's the, benefit of the module code. This is the module block, guys. And we will do multiple examples on the modules also.
What are those blocks,
And
sir? Terraform block, provider block, what are those things?
uh, every action, like when you have to deploy or manage something on the cloud, so we need these provider configuration, resource blocks. Blocks are nothing but types of code. I mean, to make it an easy way, the way you write the code by following this recommended block approach. Okay. Don't think block is something. Block is the reference word they have taken as part of the Terraform. So it is the references of writing the code. And Terraform named it as Terraform blocks. Got it, guys?
Yes, sir.
References. Don't get confused with the block word. Okay. So what Terraform resources do? It will create, destroy. So initially, I have used a word like creating and managing the infrastructure. What do I mean by managing? Managing is you created some function app, or let's take example as a virtual network. I mean, you have created a subnet, and now inside the subnet, you need to enable some service endpoints, like the Azure App Service endpoint or anything. You already created it. Now to enable, otherwise you created some virtual machine, and now you want to change the size of the virtual machine you have created with DS2 V2. Now you want to make it as DS4 V4. You want to change it. So that is called changing, is nothing but managing the infrastructure as per your requirement or client requirement. So that is like updating in place resources. Update in place resources whose arguments have changed, because you're actually ignore about all those arguments and everything. We will learn. Those are simple things. So how you're managing is nothing but making sure you're performing all the changes, and also you're making sure you have a stable environment. That is the managing. And also, in case if you want to destroy and recreate the resources, also that can be done. you want to there is a VM, but you want to remove and create a new VM with some new configurations. Even that can be done. So that's and this is the Terraform file architecture. And also, don't, I mean, by looking at these files and everything, do not think this is some very challenging code. This is an easy code. That's the reason every organization is behind this. But what are these files? These are the files. It's always constant, no changes. You have to create, right? Create the files in this way only, no changes. So these are all always the same. Provider information is nothing but the Azure or GCP. Then what Terraform instances, TF wars, Terraform state. All these are all uh, the default file structure. State is something will be created manually. You guys do not need to anything, but this is manually. Okay. Then shall we try a small example? Just to make sure how easy the Terraform is, you guys need to understand. Shall we try a small example, guys? Is that okay?
Yes, yes.
Because everyone can present and they will tell you, oh, this will do that, this will do this. But is it really going to do is the first question. When I say it's easy to learn, is it really easy to learn? Is the second question. So without an example, even you guys won't be able to understand. Let me create one folder. Sorry. Yeah, here. Create a new folder. I'll say demo. Okay. Demo. I'm selecting this folder, guys. This is the Visual Studio Code. So inside this, see, I'm creating everything in front of you. I'm not copying anything from anywhere. Am I correct? So the files I want to create main.tf. Then there are other files like before there we have seen variables.tf. All these just now we have discussed about the Terraform file architecture, how these files should be created. By default, these files will be created in this way. Okay. So if you guys can see, if I go to my presentation, the first is a string is a data type. Okay. So what we are going to do is Terraform data, otherwise not data types. I'll say okay, here I'm saying a string. What is string, guys? It is a pass some data or value. Can be anything. You guys can take my name, or you guys can take training as the name, or you can take any name over here, like ring cache or training, anything you should be able to take. Giving some input or giving some text is a string text. So when you're writing this string, you have to make sure it should be in the double quotes. The string should be always in the start and end of the double quotes. Why? This, then it will understand, oh, this double quotes is the start, and this double quote will tell it as it's the end of the string. So whatever the text you're pasting inside this, if I'm typing whether it is doesn't make any sense to you, this will be considered as a string. Excuse me. Make sense, guys? So now, okay, what I want to do, guys, okay, I want to create Azure resource group using Terraform. Okay, So this is something, as soon as you click on it, always remember you will get Terraform registry. You do not require any other website. Terraform registry is the best website. It will teach you how to access this website, how to go everything. I'll show you. So when you will have an example code also over here. Remember, you will have an example code. And here, when you're writing the code, let me just copy this code. I'm just copying the code directly from the Terraform website. Okay. This is the Azure resource group I have copied. And here you can see the name, double quotes, start and end. That means this is a string. By looking at this, you can understand example is a string. The location is a string. Also, you can see the location is a string because you have start and end. Whether you have space or anything, that is secondary, but the system will consider this as a string. I explained. So I want to make this as Rinkesh demo RG. Whatever you keep, either space or hyphen or everything is a string. I want to create inside. Excuse me. I want to create inside South India. Okay. There is one more file is required. Providers.tf. What these files, everything I'll explain you in later classes, because you guys really, because to go to this file structure, we have some other additional basics that we are supposed to follow. Otherwise, we wouldn't be able to understand these file structures. I pasted some provider configuration because this is the provider configuration which is required for us. So to execute, what is provider? You guys remember? A provider is nothing but the cloud everything. So here I'm saying Azure RM, which is nothing but Azure Resource Manager. So I'm telling my Terraform, go and connect with Azure. This is the command I'm giving to my Terraform. Go and connect with Azure. Then it will connect. That's it. Then this is the resource group I have written. I've passed the strings and everything. Now what I've done is I come to terminal. Okay. What I'm going to do is AZ login to log into my Azure account. I'm doing AZ login. AZ login is the CLI command. Okay, it's going to my account. Okay, I've logged into the.
Hello.
Yeah. Yeah.
Yeah. So small question. So AZ login is similar command to AWS configure.
Like AWS login, right? These are the commands we used for Azure.
Okay. So we don't set up any secret keys or anything like that for Azure.
I already did everything. This is my system, right? I did everything before. So it actually saved my entire, login configuration. That's the reason it's not asking me to, add my username or any other secret or anything.
Okay.
Because I regularly log in on this system, right? So it's a default already configured. But how to configure also? Yeah, please. How to configure also? I'll show you guys, not to worry. See, the resource group code I have added. Just forget about this. And I've given the strings over here, right? These are the strings I have given. So now if I go back to so what is the first command, guys, here? Terraform init for initializing the Terraform. That is what we have discussed. Terraform init, I'm saying. Just before this, everything, when you're executing, you see this is init, but I have given the command below. Init, Terraform validate. These are the commands actually. So if I maximize this terminal, so basically when I say Terraform init, it is actually initializing the backend. It is initializing the Azure RM. Do you see? This is what we have seen on the provider.tf. Excuse me, right? So that is
sorry
what
for interruption. Do we need to install Terraform in Terraform first? We can directly use the commands here.
No. Terraform CLI we have to install on the system. But as part of the demo, I want to show you how the code works. But coming to when we start the training from Monday, I'll show you configure Terraform CLI, how to download everything. I'll show you in detail way.
Okay.
Okay. So now what it is saying, Terraform initialized successfully. And now a automatic folder is created. How this has all dependencies, guys. So we don't need to discuss about it. So I'll say Terraform initialized successfully, right? Then I'm saying my next command is Terraform validate.
In case I have a small question.
Please go ahead.
At a time, three files will initialize main.tf providers and
Everything will initialize. And that's
okay.
automatic procedure. We don't need to do anything. It will
Okay.
check every file, whatever the files you are mentioning, it will check each and every file, each and everything. When I say Terraform validate, it says my success, my configuration is valid. That's the second command, right, guys? We have over here. Next, we have Terraform plan. Terraform plan. So what we have discussed, let me maximize my terminal. I hope you guys have experience with VS Code. Okay, so it says building okay, this is my organization system. Let me do one thing. Okay. I'll tell you one. Where did I save? One second, guys. I need to get some credential. Just a minute. Just one second. The login information. Allow me a minute, not more than that. Just because that's my organization login. So it requires additional authentication token. That's the message actually it was showing. The authentication token I'm unable to generate, but okay, I'm sharing back my screen, but authentication token I need to generate. That's the message, guys. So let me share back. Let me share my screen again. You guys are able to see my screen, guys?
Yes, Prince.
Yes, yes, we will.
Okay. So now we are on the same example. Okay, here, if I maximize my screen, okay, if I scroll a bit up, okay. See here, if I type Terraform validate, okay, it will tell you success, the configuration is valid. That means my code is valid. See, that is what Terraform is valid, right? It will check whether your code is valid or not. So that means our code is valid. But the thing is, when I say Terraform plan, the next thing, see, it is saying access token. You see, this is the access token. Okay, because my account, requires a service principal to be accessed. I wouldn't be able. So building an account. So this is basically access tokens is nothing but it is unable to get the access token of my account because of the permission issue. But on my next class, I will show you with the entire how we can configure this. So this is basically the code is valid, guys. Only the thing is I have issue in logging into my Azure through the CLI. That's the issue. So you can see Azure CLI. Okay, using the Azure CLI command. That's the issue. Otherwise, code is so easy to write in Terraform. So after that, these are a couple of variables, and these are the main meta arguments we have in Terraform. One is depends on count for each. You remember when we have taken the example of 100 virtual machines, I said I'll create one virtual machine and I'll make some change to the code. It will create 100 virtual machines. See, in a single shot, in a single execution, it will create one after one. The VMs will be created with the help of the for each block. These are some very, very powerful meta arguments which actually making Terraform is very superior comparing with all the other things. So these actually changes the entire behavior of the Terraform. So these are the meta arguments and very, very important and very, very powerful tools or very, very powerful configuration of Terraform. So this is how we would be having multiple functions. See, to achieve something, we have to do some functions also. So these are the functions we would be going through in our entire classes. And after that, you remember Terraform modules we discussed. So in our example, one resource, we are writing the VM code, we are creating 100 machines. How we will do it? With the help of the module. You write only one code And with this module, you repeat the code. And also there is another advantage with the module. You have 10 teams, and when 10 teams is working in different client requirements. See, team A has to write their own code, Terraform code. Team B has to write their Terraform code. Team C has to write their own Terraform code. So when you have 10 teams, so either you take any Ansible or any other language, you have to write the entire code 10 times. Am I correct, guys? For 10 different teams, where team A and team B do not have any connectivity. They doesn't work together. We have to write 10 times. Am I correct?
Yes.
Yes, sir.
Yeah.
The another advantage of the Terraform is you don't need to write 10 times. No, not required. That's all olden stories, I would say. You write code only one time and you make that as a central repository, like a central repository. Anywhere in your GitHub or in your Azure DevOps or in your Bitbucket or in your, anywhere, or you can save it anywhere. The code will be written only one time. Not 10 times is not required. One time, all the 10 teams can refer the same code and use it. That's the use of the modules. So when you have written a simple code one time, this code can be called can be called from 10 times with the help of the root module. We will call that as a root module or the module code. You write the main VM code once, 10 teams will reference the main code. That's it. They don't need to write any code. Only code is written one time. And again, 10 teams need to create 100 virtual machines. Team A 100, team 200, team 300. Everybody has to create 1,000 machines. No problem. You write the code once, and that code will be referenced by all 10 teams, and they will use meta argument for each for creating 100 virtual machine at each team. All the 1,000 virtual machines will be deployed back to back. That's the power of modules, guys. Okay.
So is it like all the 100 virtual machines will be triggering one after other, or it will start triggering it at a time?
At a time. See,
Okay.
again, that is where dependencies come. To create a virtual machine, it requires a RG. It creates a subnet because the network interface card will be associated with the subnet. So it has its own, implicit dependencies and explicit dependencies. But if any particular resource does not have a dependency, it will create at a time. Even 100 will be triggered at a time. So the Terraform will automatically, you don't need to do anything from the Terraform backend. It will create automatically everything in a single instance. It will be continuously triggering. All the machines can be done in a single shot, and everything will be continuous simultaneously, not one after one. If it is one after one, again, the same manual way, right? Create first VM, then go to second VM, then go to third VM, then go to fourth VM. Then there is no point of automation. Automation is triggering everything at the same time. So that's the power of automation. That's the modules code, and modules code is the main key for the Terraform, guys. Without module, Terraform is nothing. That's pretty much from my side. Any other questions, guys?
No, no questions from my side.
Yeah. And what you,
Sir,
I mean,
Terraform module and Terraform template, who will create? Developers or DevOps engineer will create?
only DevOps. No, developers are nowhere related to our thing. But remember, when you are writing a Terraform code, you are an infra developer. You are not a normal guy. Just don't consider yourself as a normal guy, guys. When you're writing, you are a infra developer, and the entire Terraform only our DevOps people will be writing, and the application developers or anything, they won't be able to touch our code. No access, and even we will not give our repositories to them. Everything is under control. Any other questions, guys?
As you said before, this Terraform even works for on-premises cloud, right?
Yes. You manage because you are the DevOps, you create an on-prem pipeline, and our code will be able to connect to the on-prem and manage and deploy the infrastructure.
Okay.
We will use Azure Arc is on-prem, even a virtual machines or a VMware, which is an on-prem, even that will be able to, run.
Okay. Okay.
Okay. That's pretty much from my side, guys. If you do not have any questions, I think we are good to close. But remember, that when we are doing the live example, the code is working, access token, but I'll get the access token on Monday. Then you should be able to, we should be able to do it. So as no questions, I say thank you everyone for joining this meeting, and please do reach out to the management in case of any questions, concerns. In case if you have something, just let them know so that they should be able to connect with me and I should be able to answer those.
Tomorrow, do
Sure.
we have session?
Only from Monday, I think. Please connect with Siddharth or the management. They should be able to let you know. I'm not the right guy.
Okay.
Okay. That's pretty much from my side, guys. Thanks again. And remember, just 10 days, I can make sure everybody will say that, we are very good in Terraform because I've trained hundreds of students. Many students of mine is working in different even on the product-based companies also. Yeah,
Hello?
go ahead, please. Yeah.
But knowledge required for cloud, na?
Yeah, with cloud is the basic. Without the cloud, Kubernetes, all thing you don't require, but at least some cloud knowledge is required. If you have cloud knowledge,
Cloud is required because creating bucket and data resource.
yes, at least you have to know. Otherwise, in some cases, you may not have the cloud knowledge, but remember, see, that's again, you may not have cloud knowledge, but here, if I
Because create load balancer and many services for cloud.
Yeah. As someone is asked, do we require the cloud knowledge? Yes, some basic cloud knowledge is needed because when you are configuring something, you should know where to connect and how to connect and how to deploy. Basic knowledge is required. Again, the Terraform will provide the detailed documentation, how to connect to the resources and how to do it. We will have everything detailed documentation is available on the Terraform registry. Not only for Azure, AWS, GCP, everything, we will have a detailed documentation. You should be able to go through. Any other questions, guys?
Nothing from my side.
No, nothing from my end.
All right. That's pretty much from my side. Please do connect with Siddharth or the respective management for any additional questions or anything.